probably share the link for people to find the stream, so I don't just sit in here wondering where everyone is. Oops. Okay. Get that pulled up, and here we go. We're going to be continuing with SQL. Okay, so we were looking at SQL. And we had been using Replit. SQLite. I forgot to look this up. This is such a minor thing, but in an interview or when you're talking to someone about technology, it's important enough to pronounce technologies the right way, because if you don't, it's a bad first impression with someone who will then assume, without more information, that you may not know what you're talking about. All right. And so this is a good thing that we are doing videos or class meetings so you can hear me talk about it. But for some reason, I cannot remember for sure. I just don't use this. Okay. SQL is pronounced either as SQL or SQL. I feel like people who have learned a lot about SQL call it SQL. SQL, but it's three what's that? Just drawing a blank here. Anyway, doesn't matter. It's why can't I think of that? Syllables, 3 syllables, SQL. You can call it SQL, it's only 2 syllables. All right, so you can call SQLite, okay, or SQLite. And I feel like a lot of the developers that I've talked to call it SQLite. So you can call it either. As long as you call it SQLite or SQLite, people will know what you're talking. Well, professionals are going to know what you're talking about if they've used it. It's really more of a for small things, but we only need small things to learn SQL. So a lot less overhead that we need. Okay. We are going to look at our previous example here. I'll post it in chat again too, for people that may want to follow along, or at least look at what I'm doing. And again, this is going to change as I change it, so you'll have to go back and click the link if you want to see the latest version of what I've changed. Though once we're done with the examples, I won't be changing it anymore, and you can look at it if you want to go over what we did. But use it, look at the video. So last time we looked at we looked at the difference between DML and DDL, or we talked about it, and we were using both here. And we were also figuring out some of the inner workings of Replit, SQLite, and adjusting some settings to allow us to see our output, make our output more easily readable for us. So the output here is 3 tables, okay, and I wonder if we can make it show the table name. Anyway, you're most likely going to be only pulling 1 table's worth of information in a single project here. And a lot of the table, you know, if you are asked to ask multiple questions, and now that I'm thinking about it, you actually will do that in the homework, you will not need to know the name of the table because you'll be generating it from other tables. Okay, anyway, quick review. And I've labeled these in here. So creating a table with field properties, we have the create table statement, inserting records or rows into the tables is the insert into command here. Then you tell the table what the values are going to be. So we have, here's a car called the Banana Mobile. It's yellow. It's from the year 100. And so this is how we got the information into the table here. How did we get that information out? We used the select query here, the select command, which tells the computer to generate a table with whatever you've told it to include. That's really weird. They're the same on mine. Oh, wait a second. Were you talking about the highlight here where I selected it, Wyatt? Maybe. Trying to see in the video here. Yeah, in the video they do look different. That is weird. But on my screen they don't. So I don't know. That is very weird. I wonder if I zoom in a bit here, if it would change that. Okay. Anyway, I have to wait for that to load in the video because we're on a delay. Sorry about that. Anyway. Oh, yeah. So it must be something with the resolution. It might be that line must have been floating between pixels at the time. Weird. So we looked at building it, building the database, putting stuff in the database, and pulling stuff out of the database in kind of the intro part of this. So things like building the database are DDL commands. So create table, create database. In this case, I don't think we'll need to use create database until we move on to MySQL. Let's see if it gets mad if I try to use create database. And SQLite might call it something else. Let's see. Then MySQL. Looks like you just give it a name. So let's just try hello.db. We'll see what that does. Nope. All right. In this case, I mean, I think we're stuck with one database in here. I think, just the way they have it set up. try this, though I think this is just saying that at that command line, but maybe not. And also I don't know if we're using 3. Yeah, I don't think it's going to let us do that, but that's okay because we don't need to here. Because we don't have command line access, even though it's letting me run some commands here from the thing. Yeah, create. Oh, are we already in here? Create database. Yeah. Okay, so we don't have to worry about that. Okay, so anyway, creating a database, dropping a database, or in this case, I think they're referring to it as dumping, dropping a database or dropping a table. Very heavy hitting, very high ramification level commands that you would prepare for in a business situation, because once you lose it, you may not be able to get it back unless you have to go back to the backups, and that can take time, so depending on the amount of data you dropped. All right. Was there anything else in here? We looked at those basic statements. Oh, we didn't look at update and delete. Maybe we'll wait so that you can apply those in the next PowerPoint. So very concise kind of intro to SQL there. It's really by itself wasn't that useful, but if you watch the video, it's better. Okay, so because we designed our database already, or we learned how to design a database already, now we're ready to do the last step, which is build it in the database management system, and we're going to use SQL for that. All right, and so for us, we won't have to do this step, creating the database. We'll learn how to do that when we get to MySQL. Creating a table is similar. Use the create table command. Give it a name. Has to be one word. And then we just provide the fields. If we need to, we can give it a length. If it's a alphanumeric data field, maybe we want to limit the size. And then we list our constraints. Those are our field properties can be constraints. And things like, does it have to be unique or can it be null? Remember those. Setting the primary key and the foreign key constraints, which we did here. So here we have an example of creating a table that works. Okay, and we did this in the last video. The name of the table is here, and then after that, separated by commas, are the fields: car number, car name, color. Okay. And why is this? Oh, so these could all be on the same line. Remember, I said before, it's going to read all of this as one line until it hits a semicolon. So the reason you don't want to put this all on one line is because it's much harder to read. Here at least we can see, the field name, the data type, and then we can list the constraints after that. We'll talk more about those later. So once the table is created, we now have the ability to insert records. All right, so creating the database is probably going to happen once before you start using it, once you have all the bugs worked out. And inserting is going to be happening, depending on what it's used for, inserting can be happening a lot. So you're probably not going to hard code every insert. You're not going to whip up the database, get to the console and type in insert into and have a stack of forms and just type in. What you're going to do is, this is just an entry point into the database. you will connect it to some software, and then that will give access to some program that can put the data in for you, and you just have to write the queries to tie that together, which that would also be done by developers. At this point, you might be both. You might be the person designing the database and also developing the software to work with it. It's more common now with web apps. Okay, so we're inserting records, and we can see those in the output. This is just, let's label this. What's the comment? Oh, it's 2 dashes, right? In SQL, a comment is 2 dashes. We learned that last time, and I just remembered it. So this stuff is for changing output display. So you should only need to include this once in the beginning, and then you won't need to include it again. What was I doing here? Oh, this was putting a blank line between things. Let's try not putting a blank line here and see what it looks like. It's a little squished together. So here's the, if you want to put a blank line between your tables, that's what this is. You can just copy these 3 lines of code, stick it between your select statements. This is something you probably won't need moving forward outside of the class, because rarely are you going to be using the console here for anything more than testing, because the output will be fed to, again, some sort of software that'll organize it for you, or have a developer take that and organize it how they want into the user interface. All right. So we looked at creating a table. This was for creating a database. Actually, this is also for creating a table, but because what we're doing right now, every time you hit run, it creates the database, runs all your commands, and then it's done. Everything you put in there is gone. So when you rerun it again, it has to build it, which is not how the databases we're going to be using are going to work. They will persist, and when we get to MySQL, we'll use this if not exists to simplify updating the database. But it's all for testing purposes. Okay, we need to know data types. So for now, our numeric data type in SQL is called int for integer, and our alphanumeric, so for words and letters or even numbers that don't have a value, they just have a meaning, we use varchar, and the number here is the length of the field. So if we do this, it can only hold 30 characters. And so if there are 1,000,000 records, we will know that's 1,000,000 times 30 characters worth of space being used up at a max. Okay, so another data type that we need to become familiar with that's really important for databases is date time. So this is talking about how it works in MySQL, but it's similar in the way you calculate date time in a computer is similar. How a computer calculates date time. So it says many computers today. Well, that's not the best answer. Where's the best answer? Here it is. And you know, because that's the check mark. Every computer has a system clock, so it keeps the information there. depending on your language, date objects, yada yada. Okay, so that's a very broad overview, but this is more specific. A computer is storing a count of how many certain units of time has gone by since a specific time and date in the past. In Unix systems, for example, this could be the number of seconds since the Unix epoch, which is midnight, January 1st, 1970. So it counts seconds since, or the date time data is actually just a number which represents the number of seconds that have occurred since January 1st, 1970. All right, and so then it just calculates out, well, which years were leap years. There aren't, converting that number of seconds plus this date to equal whatever current exact date and time it is. That's for Unix anyway. And so here, when you use the date, and one of these data types, date time, timestamp, or year, it is actually calculating that based on that number, which it pulls every time you need to get the current time. And so it's just saving the number. If someone buys something and you want to save the date in your transactions in the database, you have a date of transaction field, you can just tell the computer, okay, in the software when they press the button, it'll probably save that time as the number of seconds or whatever, and then transfer that to the database where it can be stored as a number, and then when it needs it, it can calculate out when that is. Some people also just store it as a string, but it can work a lot faster with that number. And you could actually use date time without ever understanding that it's just a number, but it makes it a lot harder to manipulate it unless you understand what it is. And you can't, if you store it as date time, you can add things together and subtract them to get the number of days between two dates, or the number of seconds between two dates, and have the computer calculate the number of days for you. And so it could do things like calculate when a late fee should be charged, or when a credit card bill collects interest. I can only think of negative things right now, but there's good things too. Like when you can legally, when you're of the legal age to do things, and which are always usually vices, right? I guess voting. There we go. When you're the correct age of voting. Correct age to vote, I guess. Okay. So, in SQLite, let's see. Now I'm going to say it that way. Because now I know that it only has 2 syllables. To save time, I'm going to call it SQLite. Okay. We'll look at date, time, SQLite. But now that I'm saying SQLite, I want to put 2 L's in there. And that's why I called it SQLite before. Date and time. Okay. So, it can recognize a certain format of strings to take in a date, but you have to be exact here. Year, month, and day, hours, minutes, and seconds. Okay. If you want the output to be different than one of these, you can use these kind of placeholder variables to build what it looks like. But we aren't worried about that yet. Does it say? Okay, so here the datetime function returns this string. Oh wait, never mind. Time strings, modifiers, and then they have some cool examples here. So if we did select date now, let's see what that would output. So this is using a function that's calling code that will calculate something else out for us. That's what this part is doing. So we're calling the date function and we're passing in the argument of now, and that will tell it to return the date. So this will become the current date, and since we're selecting that, that will build a table out of this information and output it in the console. So it is 10/26 of 2020, and if we want like the amount of time, we can do date time. See what that looks like. That adds in, it looks like up to the number of seconds. So it's in military time. So 3, or in the 24-hour. Translating human techniques that help us remember times and simplify things generally complicate things for a computer. So that's why they use the 24-hour thing. Here's the thing. It's stored in here as 24 hours, but when you output it, you're not required to output that. You can probably tell it. Let's look at the format. So you can pass in the format you want. So let's try for date, changing the format so you can see what I'm talking about here, instead of just there's nothing wrong with sitting there and nodding and as long as you're paying attention, but I feel like it's much more valuable if I can show you an example in case you are like, okay, I'll have to look that up later because you didn't talk about it. And there's a million things you're going to encounter that I didn't talk about, but let's see what this does. Okay, I've got an extra thing in here. Well, let's leave that for now. I just forgot my semicolon. Alright, so that is not what I wanted. And it might be this. Whoops. It is probably that. Needs to be that. Nope. Okay. Oh, I'm sorry. This is a different function. So this is strf time, string format time, that allows you to change the format of the string of the output of the time method. So let's use the correct method here. If we want it, the output to be different, we do this. Okay. Maybe. Okay, format, time string, modifier. So let's do, this is only formatting the time. Maybe we need to provide the actual time. Okay, in MySQL there was a function named now, I think. Or maybe I'm thinking of nope, that's not working. Okay. How do we change this format? I don't have any good examples here. maybe this goes to the documentation with better examples. Here we go. Oh, what is this? Okay, so we have to specify that's the pattern to use. No examples. So let's do this. SQLite strf time example. Okay. Okay, we know all that. We know all that. Did they just go and copy and paste? No. Here we go. Okay. It's just now without. So we just put the name of the function. We don't call the function. We're telling it which function to use. There we go. Nope. Still not working. Select, yada yada. Okay. Extracting month. Extracting year. Alright. Let's try an example of what they have and see if that works. So we're doing this so we can discover what we can and can't do in this Replit thing, because we'll have to see what version it is. Okay. No, it is working. Okay. It is working. Because we are selecting this, what it's going to give us is this is the field name, and then the value of the result is under that. That's why there's lines in between here. So this one is saying, well, let's get rid of the other one so we don't have to be confused. And let's get our new line here between these select statements, so it's not a giant garbled mess. Alright, so here it's taking the year, month, and day, putting dashes between them. If we want forward slashes in there, we could do that. Maybe that's the format our company prefers. That makes it slashes. We could put year, month, and day, like so. And probably put some spaces in here so you can read it, right? So here it says the year is 2020, the month is 10, and the day is 26. Do you see you can control the output? These are just variables that reference pieces from the variable that's stored as time. So it's not showing you the value that's stored in there. It's showing you the output. It's obscuring the translation of the value stored in there into the output. Okay, anyway, we'll definitely need to know how to use that date data type. And the reason it's on here is you just saw how complicated it can be. Oh, here we go. What if you're dealing with someone that flips around their month and day? And by that I mean an entire country that does that, not just one person, right? We're becoming more global. The world's becoming more global. You need to be aware that people organize dates differently. They use the metric system. They use Celsius. And if you sit there and you say that's not the way to do it, we're actually outnumbered in a lot of those categories, and so you won't get a job. And the people that say, okay, I'm willing to learn these other things, will get a job. So don't keep yourself ignorant, or you'll get left behind. Okay, so maybe they flip around their months and days. And maybe they want to put year last. And you want to make it easier for them to understand. So we could do day, let's do month, day, year. Because I think that's No, let's do day, month, year. There we go. That's the one that we're not used to. I think. Correct me if you're familiar with that. If whatever in your job or in your experience you've ever used day, month, year. So 26/10/2020, the 26th of October 2020. Just so I'm not wrong here, let's see date formats globally by country. Here we go. Okay, so in Afghanistan, every country, they use year, month, day, and day, month, year. They do not use month, day, year, which I think that's the most common one for us. Probably, I mean, who knows? Probably not going to be designing, if you're planning to work locally, you probably won't be working with anything dealing with Afghanistan, but I could be wrong, so now you know how to figure that out. Canada uses all three. Ghana uses all three. So they've got some, Canada and Ghana have something in common that you may not have known. A lot of them don't use a lot of these. Everyone that doesn't use, and you can tell, it's probably here, month, day, year is the last one because it's probably the least common. And so it looks like, yeah, it looks like that's the least common. And look who uses it. People that we directly have worked with in the past. So Canada, that's our neighbor. All these places in Africa, Japan, these are people we do business, these are countries that our country does business with, and so probably at some point they were like, okay, we got to adopt this because they're not going to change. Okay. So being aware of that is important. And you may say, hey, I'm taking a class about databases, not about world culture. Getting a job in today's day and age, understanding world culture is basically a requirement. Different cultures. Just understanding that different cultures do things differently in certain ways is enough. And I'm not saying you have to go and memorize this date format chart, but you just need to know, remember, different countries represent dates differently. Let's check in this situation what the best way to use is. United States. And this is how you can tell we are set in our ways. Not that there are other countries that aren't, but we use this one format, which is a good idea. If we could get everyone to use the same format, it would be a lot easier. But which one do we use? We're not going to change, right? Why should we change? Why no? And so that just creates a situation where everyone's using. Luckily, there's only 3, and then, at least in this Wikipedia article, who knows? Some people may have, some cultures may calculate a different number of days in a year. If that's going on, though, you're probably not going to be programming something regarding it. Okay, anyway, we're getting down in the weird stuff. Okay, so anyway, dates. Oh boy, they sound fun, don't they? These are MySQL functions for getting date information. Don't get this confused with things for SQLite. We will Google those as we need them. When we start using MySQL, we will go back to these. All right, and here's a list of field constraints that I'm sure this is from MySQL. Oops. DQ. That's not right. MySQL example. Okay, so I talked about null and unique, primary key, foreign key. You can also set a default value. So if they leave something blank, it'll put some value in there for you. So that way null doesn't end up in there. Auto increment, this one is cool. If it is a integer, then every time a record is created, it will pull the next value for whatever increment you sent and use that number. So if you're creating arbitrary ID numbers for things, this is a good way to prevent someone from having to go, what was our last order? And have the computer keep track of that for you. And then the number is just for reference at that point. The computer, you need the ability to put in the number and the computer tells you the details about it. That's what this is for. This is how you would do it in SQL. Let's look at auto increment in SQLite to make sure it's similar. And it's nice that we have this documentation here on this. This is a site, I believe I've had students use this before for personal projects that I've given them, and internship research. So becomes recommended by previous students. What are we looking at? We are looking for auto increment. So let's try increment first. There it is, auto increment. Then we'll compare the syntax. You just put the word auto increment after you put the data type. Okay, and it looks like it can only be used with integer. And it doesn't look like you, in this example, you can change the increment from just 1. So let's make sure we understand if you can do that. That way, if we ever need to do it, we can. So auto increment. Okay, this is the official documentation. So this is a really good place to look. Auto increment keyword imposes extra CPU, memory disk space, and disk input-output overhead. I feel like last time I made a big deal about, or at some point, minimizing input-output to the hard drive, or to the disk with a K. Okay, and so from a developer, knowing that we're going to be using this with development, whatever software that you have communicating with the database could do the auto increment so that it doesn't have to be done by the database management system. But since we're not there yet, let's have SQLite do it. Okay, where's some syntax? The keyword. Okay, I'm not seeing anything regarding Okay, they're telling me all the things to watch out for. But the big important thing here is to understand we can use something like auto increment, but apparently they're telling us there's usually a better way to do it. Let's go back. We're going to copy. We have car number here, right, inside of the create table command for car, the cars table, and we're just manually putting in some random numbers here. Let's put it in. Let's have it use the auto increment. So I won't need to insert a number anymore because it's going to pull that for me. So we're going to have to update our insert statements to let it know we're not going to be telling it the number, car number, anymore. Okay, so we can get rid of these. We're not hard coding those in anymore. And we're going to set car number. To be able to use this, remember, we have to put it as an int, so we'll change the data type to int, and then we just put auto increment. Some extra e's in there. Okay, auto increment. So we will increment by 1 automatically on creating new records, which we're doing here. So if we're going to insert data into specific specific columns or fields, we need to specify to the insert statement the order we're going to insert those in. So we're not inserting car number anymore, so we don't include that, but we are inserting car name. We are inserting year, and we are inserting color. So now it should know the first value is car name, second value is year, color is the third value. All right, and we can do this, I think. Let's try it with 1, and then we'll go back and fix the other ones. We can just list our inserts in like this. Okay, year, auto increment. Should be changing one thing at a time. Car number in auto increment. No such table, cars. Well, that's what this line's supposed to do. Oh, that's something else. Okay. Did I type it wrong? Auto increment. Did I make a typo? Auto increment. Create table, oh, it's into, well, I don't know if this is requiring the keyword integer, maybe. Nope. Okay. I wonder if they've deprecated this. That'd be interesting. Okay, Why no work? Okay, table cars. So usually, if you have an error like this, so the code's read from top to bottom, this is a debugging tip. Code's read from top to bottom. If you have an error on a line here, especially in SQL, that's probably going to cascade into all these other errors. So I just ignore these. And it's on line 2, which, remember, all of this is line 2 because it's everything before the semicolon. So be careful about that. The problem is not going to be after this. So I start here and then I look above. Well, there's nothing else above this, so it's got to be somewhere in this line. Got comma, 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 comma. Sometimes it's easy to include an extra comma. And oh, it says near auto increment, which means it's either here or before. Maybe they changed it so if we do it this way, it knows it has to be an int. No. Maybe it won't let us do it in here. Let's go back to the official documentation. Keyword. Column with type integer primary key is an alias for da-da-da. Insert. It will be filled automatically with an unused integer. Okay. Here we go. Create table, blah. Test, blah. They don't have any examples on here. That's so weird. Okay. Increment syntax. Okay, now this is an appropriate example for Stack Overflow because it sounds like someone okay. So you can only auto increment if you set the field as primary key, and we're doing it the MySQL way, which I think was working, but is not recognizable by the auto increment. So we probably have to promise it will be there by including it here. Okay. And now it says, 1, 2, 3. Okay. I took out the numbers for all of these. So cars table it knows has 4 fields, but I'm only providing 3 values. So that's why I'm getting that error. So all I have to do is include the specification of which fields we want to insert into. Okay, so there we go, and we can get that here. And so what that tells me is this worked. We can just put if we're just going to insert a bunch of rows, we don't have to include the keyword every time. We just need a comma. So that works in SQLite. There we go. That made this a lot more concise. And we can just put each row on its own line to make it easier to read. Look after values, I look for the comma. Then we'll push that down to the next line, after the next comma, down to the next line, and continue on. And that way we can see, okay, we're adding 4 records. You could even, to make it more concise, you can see it that way. Okay, everything's working perfectly now. Okay, we've got some people in here watching. How overwhelmed are you versus how slow does it feel like it's going? This is one problem with the online learning, is I can't see your face and the look of panic or the look of boredom, which do not offend me. They are valuable indicators of how I should proceed. So now I rely on you to tell me, because I can adjust to make sure everyone can learn and not get overwhelmed. Anyway, we changed that insert. Why were we doing that? Oh, for the auto increment. And so here you can see every car. We're not telling it that Banana Mobile is car 1 or Apple Mobile is car 2. It is auto incrementing for us. So we were demonstrating that. That got demonstrated. Not null. That, remember, not null is saying it cannot, this field, do not allow a record to be entered with a null value in this field. And then unique is saying check the values for every other record to make sure what I'm entering is unique. Okay. Primary key constraint, that is specifying that it has to be unique and not null. Okay, that's just bundled in with that. But it also helps set up foreign key constraints so that if we want to delete records, let's say we have another table besides the cars table with customers, and we want to link together which customers bought which cars. And so we have a record for Bob, and we have another table that keeps track of all the cars Bob has ever bought from us. And then let's say later we want to remove Bob from the system because the information is no longer useful. If we just remove him from the customers table, can you foresee any problems occurring? So we have records of what Bob has purchased in one table, and we have the information about Bob in another table, and we want to get rid of the information about Bob. What happens to those records of what Bob purchased? They know that that information is just stuck there, and it means nothing, and it's wasting space and efficiency. Now we have to search that useless information every time we query. Using a primary key and foreign key constraint will allow you, when you try to delete Bob, it'll say you can't do that. There's like 38 records in varying tables that need that record to see, to know who it's attached to. And so then you would say, oh, okay, you go in and get rid of his records, or do something with them so they can be taken out of the database, save them externally or archive them, or just delete them if you don't care. And once you got rid of all those records, you can go back and delete Bob. That way you don't get all that stuck, just useless data stored in your database. That's all the primary key and foreign key constraint do. You can still use fields as foreign keys and primary keys manually, but then the computer can't protect the data that's going in those or being deleted. Okay, so foreign key and primary key, we'll be able to specify those. The default, this allows us to create a value that will be used if we don't provide one. So we'll just look up, because again, I don't know the syntax for this specific, for SQLite off the top of my head for default, so we just do default, SQLite default. And here we're back to the official documentation. And what are we looking for? We're looking for default. So how do you specify the default? By default, the default here, inception, the default of the default is null. So if you don't change the default value and you don't have a way to prevent null getting in there, it will use null, and we want to avoid that. So we can set a default and you want to use this when it makes sense. Otherwise, if there is no default that makes sense, you want to make sure that it's not null. Explicit default clause. Where is an example? They do not like to. They do not like including examples in here on this official documentation. Probably because this doesn't have nearly as much support as other languages. Alright. Well, let's just try to use it the way it's used in MySQL. So we'll just say default. Car. So the name will be car if we don't provide a name. Okay, make sure that, okay, it's not giving us any errors. So let's do, we can just say, instead of specifying, well, let's see if this works. No. You have to specifically not specify it. So let's say we just want the year. We're going to insert a bunch of year, color, cars, and we don't care what the name is, so it'll just put car for each one. Okay, but I like this example, so we'll pull both. We'll insert both. So since we're inserting a different number of fields in this insert, we have to update that, and we're no longer going to give it a name. So I can use control click to drag over these. Like so. They're all gone. But I forgot the comma on the first one. So I have to fix that. Okay. Got all those. Okay. So now we have 8 cars. We're inserting 4 here, and we're inserting 4 here, but these ones have names. These ones we did not provide a name, so it put in the default value we included. So you can do that. See if you people watching can think of a field where it's good to have a default. Okay. Any kind of field where you're storing information about extra options. If you don't have information from someone about whether or not they want this or that, or you need their specific approval, you can default to no on those kind of things, or default to whatever the default of the organization would be. Okay, so defaults. Don't default on your credit cards. That's not what this means. Okay. Okay, when you want to get rid of a table, you want to drop it. Let's see. We're not gonna worry about deleting tables yet. Okay, but there is a way to add and remove fields from a table. There are ways to delete tables and recreate them. This probably won't make a lot of sense until we get to MySQL when our database is persistent, but you can save queries as a virtual table, and then you don't have to rewrite the query code every time you want to get that. So let's see here where I have the select cars.car name, year, and color up here. If I want to, well, that one's not that complicated. Let's do one where I did something complicated. So this filter query where I only want the cars that are newer than the year 100 and that are red. Let's say, you know, I might be using this one a lot. I don't have to retype all this every time. I can create view. I'll call it new red cars. That's the name of my view. That'll be my virtual table. And that word virtual table means it never gets stored in the database. I don't need that. So select. At this point, you can just put in the query. Down here. Why was there an as in there? Oh, that's the keyword to tell it what the query is. Okay. So just paste that in here. So that will create it as a view. Let's see if this is correct in the syntax. All right, no errors at least. So now I'm doing it, I'm calling it here. I am creating it as a view here. But let's get rid of it here. Now let's keep it there because I want these notes for you guys. Creating a view as a working example, you know. Yeah, I did post this. Okay. So we created the view. So let's say we want to pull that information up again at any time. We can just do select star from new red car. The fact that that rhymed was a coincidence. And now down here it says no such table, new red car. Okay, so let's see if they even have views in SQLite. Views, because they're useful in MySQL. It's probably just a different syntax. Create view statement. Create view name as, then the select statement. Okay. Default, the columns of the view derived from the result. Okay. Create view example. Calling query. Okay, so they're saying, okay, here's a complicated query. And this will get there to where we're able to parse this and understand what this is doing and write these ourselves. And so here they're doing create view name of it. I did that right. All right, create view. Oh, that's up here. Create view. Did I spell view right? Yes. And then a name. And then they have the as here. I usually put it on the line above, but we'll see. It's all in the same line, so it shouldn't matter. New table, new red car. Did I? Oh my. I called it new red cars. Sorry. Okay. That was my bad. Alright. And so now, anytime I want to get the results from that specific query, I can do that. Let's say someone I call that out. Someone adds a new red car in there. Okay, so we'll call it first, and then let's say 12 days later, we get a new car, and it's called Ready Mick Red Car, and it is from the year 2000, and luckily the name matches the color. Okay, so we can add that in, and then we can run our our virtual table, the query we created, just by using the name. And don't forget your semicolons. All right, so here, the first time it gets pulled, it's pulling 2 and 6 because they're red. Then we've added the new one, and then we're using the same thing we saved, and now we can pull the old ones with the new one. So we have Applemobile, car, and Ready McRed. Now, it didn't put car in there because we specified that these car names can only be 15 characters long. And so, hey, oh no, we have cars that are have longer names now. Maybe it's time we increase that limit. In this case, it's not that big of a deal. If this has been in use for many years and you have a lot of these records and you want to adjust this, it could be fairly cost intensive time-wise. So, I'm doing this to demonstrate, but remember, this is in the scope of we're testing it before we're going to use it, right? You don't want to do this unless you have to, in the live thing. Okay. And maybe it's just not showing the column widths. So let's see. You might need to be able to see this later. I wonder if you can adjust. SQLite column, or output column width. I wonder if it's based on the field. Best answer says you have to compute the column widths by hand. I don't want to have to type width 210.5. So it looks like you get the fun job of specifying which widths of the columns you want in your output. So if we want to see, this isn't usually a problem. It doesn't matter if it's only showing me this many unless I really need to know what's in there. When I pass the data, it's there. Well, at least 15 characters of it were now 30. And so we can do, we want car name, which would be the second one, to show 30 characters. The first one is the car number. We only need 2 there, or maybe 3. Well, how many cars are going to be in here, right? And we'll do that. So let's say 5 digits for now. How many cars does a car salesman sell? All right, and then we had year and color. So we can just do 5 and 5, I guess. Let's do 10 for color. There's some weird colors. And there we go. Now, this is adjusting output column width. Okay, and just labeling that so you can see it. Let's put some of these blank lines in here so it makes things easier to see. Hopefully this isn't just making it more confusing. Alright, so now we can kind of see what we're doing. Oh, up here when we were doing the time, I wanted to show you aliases, because this is confusing to see this. Let's see if it works in SQLite. When you are choosing the columns that you want to include in your output, you list them in the select statement up here. This is the column I want. It is this calculation, so this is what it's going to be called, but I can give it an alias. We'll see if this is how you do it in here. And so now it'll rename that field to time, because I said, okay, this will be the first column, but you're going to call it time. So as time, that's the name of it. And you can do this anywhere, so maybe inside of our view that we made right here, virtual table. And the reason I keep saying that is it's important to understand this data. When you create a view, you're not storing any of the data. You're literally only storing this query, which when you use the view, it'll call the query. So this one is saying select star. I guess I don't want to waste my time adding all that because I need to go here. Let's do one where we are selecting the specific. Here, do I still have one? Man, I'm using way too much select star. Okay, so here this one's called car name, so we could set that to as car, or let's just say name, as name, the year, as, it'll use the default name that you've used, which I like to use all lowercase names in my fields, because I know that the person that's developing it is going to have to reference it by that name, and if I capitalize things all willy-nilly, it's going to drive them insane. And if they go postal, they know who did it, and I might hear a knock on my door. So just to be safe, you want to follow some sort of standard of naming, because you can just change it in the output here. This won't affect what the developers use. Okay, cars, year as year, and then color as color with a cap. So now when we see this one, it says, which one was this? No errors. See how these are year, color. It feels like that's not working here for whatever reason. Not sure why. Huh. 'Cause it worked down there. Maybe I need to clear it first. Yeah, it just wasn't clearing out the old output. So be aware of the button on the right here to clear your output, so you're not looking at the same wrong input or output every time. Okay, so you can see now it says name, year, color, all caps, instead of having year and color. And I should have specified these as lowercase for the first one. Anyway, wherever you're using it, you can talk to the people that are going to use it and ask them what they prefer. All right. Well, I think that's enough about SQL. Where are we at on, for today anyway, where are we at on assignments here? 26th, what do we have? Adding field properties, all that. Chapter blah blah blah. November 9th. Oh yeah, you guys are working on the take-home midterm. Don't forget to have that in by November 9th. That's still plenty of time. Okay, SQL intro, October 30th. I might push this back a little bit, but let's see what it says. Read chapter 3 in the following book. You will complete exercise 3.1 on page 105. Enter your queries in the text box below. Anyone start working on this? I hope not, because I'm going to be changing that quite a bit. Nope. Okay, good. You guys were smart to procrastinate on this one. Basically, if I haven't talked about something in class, you're most likely not prepared to do it without a lot of work on your own, so. Good question, Andy. This assignment that I gave here is after you've basically gone through the entire SQL thing. So I'm probably going to ask you to do something else instead of this. Let's see what these questions are, and I'll limit it down to the ones that you can do. And you were saying that, yeah, the book is using a different syntax, so you will have to learn how to do it in SQLite. Most of it should be as simple as the stuff we looked at today. The syntax might be slightly different, but you can look up the documentation and use Google to find examples. You have to become self-sufficient in learning this stuff eventually, but now you have me to help. So okay. Oh, I need to find the book that I'm using, and I didn't want to re-download it. Textbook. This is actually the textbook I used in school. So that's how you know it's good, right? Let's see when it's from. 2011. So there you go. Little old now, but you know, the actual what we're learning about SQL has, and is this stuff about relational databases, has not changed. The reasons why you might do one thing over another has, but that we aren't there yet on the implementation side. So what page does this want us to look at? It was page 105. Which is in this book. No, that's not the book. The book is this file that it opened in Edge. Thank you, Edge. 105. That puts us on page 78, so we need to go like 27 higher than that, so 133 or something. Ooh, so close. It was 131. Okay. Write the following queries in SQL using the university schema. We suggest you actually run these queries on a database using the sample data that we provide. I think I have that data available for you. Okay, find the title of courses that have 3 credits. IDs of all students who were taught by an instructor named Einstein. That one, these you can't do because we haven't talked about joins yet, so, and we haven't talked about aggregated functions, so we can't find some. Oh, and we haven't figured out how to sort yet. That's all stuff we'll talk about next time. So, you know, maybe we'll put this stuff off, and I'll just make another. We'll use the same data though, so let's see. Don't worry about any of this stuff for now. Here is the SQL file. If this can be copy and pasted into SQLite, we're good. If not, we'll just use the one. Oh no. Oh good. I thought it would select the page or the line numbers here. That would be a nightmare to fix. I'm gonna have to write a script to strip those out. Okay. So I'll create a new, and I'll give you this link. This is good. I'm glad you brought this up, because it's good to start practicing at with what we've learned so far is more than enough to practice. Need to practice before we move on. So let's try copying this in and see if it explodes. Oh yeah, we don't need the create database command. Okay, so one line we don't need, and I think it's done. So let me test something here, because we're not outputting anything. So select star from, and what was I don't even remember what the tables are called. We have classroom. Select star from classroom. We'll see if that pulls anything. All right, so you can pull information from this. So down here above is the database schema, or the architecture, or basically what we've been designing the first half of this semester is the database schema, which is basically how it's laid out and the organization of it. And once it's locked in, you should assume that you're not going to be changing it. Okay, so I will give you this as your starting point and create a new assignment that does not include things that you don't know how to do, because that's very frustrating. It was this one, so we'll just replace that for now. Go ahead and turn this off so you guys don't have to worry about it. And we will do SQL 1 exercises. Okay. And we'll give you guys a week on this. So let's go for the 31st. Okay, if you have plans for Halloween, make sure you get this done soon. Wait, no. That's not a week. The 2nd, November 2nd. There we go. So if you are worried about the election, make sure you get this done sooner so that way you have time to prepare. And we should give you some tasks. So write the select statements to print out each table. That's number 1. Okay, it always aggravates me when I try to use the bulleted list in here. For this, but let's see if I can do it, because if I add or change things, I don't want to have to manually change all those numbers. Okay, so that's 1. Write the select statements to print out each table. And let's go in the first table. They want to use, what are the tables? Classroom. Let's have you find in number 2 find the classrooms that have capacity go down to the insert so we can see what the heck. Insert into classroom. Do we actually have anything in the classroom? Is that what I searched over here? Probably. Yes, so luckily I've pulled that information out. So we'll say classrooms that have a, how can we get classrooms that have a capacity greater than 50? greater than 50. And I better be more specific here so you guys aren't confused on what I need. So you're going to write a select statement to find the classrooms that have capacity greater than 50. Okay. It also, we have students in here, I saw that. So let's do can I type right in here? Yeah, select star from students. Okay, select star from student. And I always forget to put my semicolon here. Okay, so we have, these are our students. Let's do all the ones that have a major of physics. Write a select statement to find the students with a major of physics. Okay, and you should be able to find examples in the example I created to help you figure this out. And again, as always, you can ask me questions. Let's look up, let's do one more. Instructors. Did we talk about the and thing? And why did I lose that? What did I call it? SQ. We'll use this as your examples to build from. Okay, and this SQLX1 will be the starting code. Starting point. So you're gonna follow this link. For the assignment. Link for the assignment starting point. You'll click here, and then you'll just edit this with the solutions to these at the end, and you'll see the output. And I'll compare that to what the output should be, and then we can talk about problems people are having. And then next time we will definitely go over additional clauses for more concise queries, because, excuse me, as soon as you learn all those, you can basically ask a database anything you want. And then it only matters why are you asking it. Okay, so I was going to check if we had done a multi-condition filter. If not, I'll just throw that in here real quick. So we'll do this here. We want to find cars in this example that have we are doing one here, because this is finding cars that are have a year greater than 100 and that have a color of red. So you can see how we did two conditions there. So we'll have you find the instructors select star from instructor. Okay, so let's get the ones that are in the computer science department with a salary greater, yes. Computer science department with a salary greater than 65,000. Instructors in the major of comp sci. That might be department or something. In the department of comp sci with a salary greater than 65,000. Don't get any ideas here about higher education salaries. You know, at a four-year university, that's probably on the low side, but at community college level, that is, we'll just say I take a lot of, I do my job because it makes me feel good, way more than it makes me rich, which is more valuable to me, so that's why I made that decision. Anyway, Department of Computer Science. It has to be capitalized because it's official. Okay, one more. We'll do one more here, even though at this point we're kind of repeating ourselves. Let's do, and we'll just use another one of the tables here. So we also have classroom, department, course, instructor, section. Let's do section. Find a section. So as you guys are registering, you can see now when you're searching for sections to register for it, this is what's happening in the background of the computer. It's pulling out the information here. So the course code, I don't remember what this is. Maybe it's, well, here's the semester that it's being offered, the year it's being offered. These must be the instructors teaching it, and this is the classroom, and let's double check that before I make you do something that doesn't make sense. We want like the first one here, so I don't need to be searching. Section, we have course ID, section ID. Okay, so that's if we have two sections of the same thing at the same time. So here, for example, we have CS 190, spring of 2009. There's two of those, so we need two sections, the first section and the second section. Okay, so what can I ask that would be good? How about how many sections have, what the courses that have two sections? Sections of courses that have, sections of courses that have two sections. Okay, that sounds confusing, so I guess we'll just you wing it if it doesn't make sense, and we'll you know, I'm gonna allow corrections on things, so try it yourself. Don't be afraid to try whatever. Okay, and we got a week. You're doing 5 things, so let's give you 3 points per thing on average. Probably weight some of those points more towards the difficult ones. You know how it goes. And you will be submitting the link to your Replit. So let's make sure I put that. Edit the starting point to include the above queries so that when I run it, the output is correct. Submit your Replit link below. All right. I think that should be a lot better than the existing assignment for now. And we'll publish that. The other one's unpublished. We should be good to go on that. All right, and you've got enough information to do that. If you don't, or you need anything explained, definitely email me. We can set up a meeting. Otherwise, you folks have a good day, and I will see you in the next video or in a meeting. Also, if you haven't scheduled your advisor meeting, make sure you do that. Just email me for information. All right, have a good day.